Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to go over how to classify a triangle based on its angle measures and side lengths, and complete some example problems on classifying a triangle. I'll then review 3 important properties of triangles and complete some example problems on finding the unknown angle in a triangle. We'll begin by looking at how a triangle can be described or classified. Triangles are often classified based on their angle measurements. Let's go ahead and underline that. And on its side lengths. There are 3 ways to classify a triangle based on its angles. In our first triangle, we have a triangle where all 3 interior angles are acute. That means that the angles are less than 90 degrees each. So these 3 angles are all less than 90 degrees. This triangle is called an acute triangle. In our second triangle, we have a triangle where one interior angle is a right angle, and that is 90 degrees. And that right angle is indicated by our square mark. This triangle is called a right triangle. In our last triangle, we have a triangle where we have one interior angle that is greater than 90 degrees, and that's called an obtuse angle. And that angle is right there. So this triangle is called an obtuse triangle. So based on angle measure, a triangle can either be acute, right, or obtuse. There are also 3 ways to classify a triangle based on its side lengths. Our first triangle is a triangle where all 3 sides are of equal length. We can indicate that in our picture by drawing a straight bar on each of the sides, and that means that all 3 sides are equal. This triangle is called an equilateral triangle. Our second triangle has 2 sides that are of equal length. So let's underline that. 2 sides of equal length, and the third side is a different length. So we can indicate that in our triangle picture. So we have 2 sides that are of the same length. We'll indicate those sides as 1 bar. And then the third side is a different length, and we'll indicate that by having 2 bars to indicate the different sizes. This type of triangle is called an isosceles triangle. Our third and last triangle, we have all 3 sides are of different length. So we're going to have a different mark on each side. So our first side has 1 mark, second side has 2 marks, and our third side has 3 marks, so that we can tell that all 3 sides are of different length. This triangle is called a scalene triangle. Let's now do some examples where we're given a triangle and we need to classify it. So we're going to classify each triangle by its angle measure. So let's just write down our 3 choices. It could be acute, it could be right, or it could be obtuse. And we're going to classify it by side length. So our choices for side length are equilateral, isosceles, or scalene. Our first triangle has an angle of 90 degrees, which we'll indicate in red, and it has all three sides of different length. So we would classify this triangle as a right triangle, and because each side has a different length, it would be a scalene. Our second triangle has an obtuse angle. That's a little bit hard to see in our picture, but I'll assure you that that angle is obtuse and it's greater than 90 degrees. And we have two sides of the same length and one side of different length. So our triangle is going to be obtuse and isosceles. Our last triangle has three acute angles. Those are a little bit easier to see. And three sides of equal length. So this triangle can be classified as acute and equilateral. In this next section, we'll look at three properties of triangles that are helpful to know when we're working problems with triangles. The first property says that the sum of the interior angles of a triangle is 180 degrees. So if we look at our picture and look at the labels in our picture, we can say that angle A plus angle B plus angle C is 180 degrees. And it might help if we go ahead and add angles to our picture. The second property says that the sum of the lengths of any two sides, so let's underline any two sides, is greater than the length of the third side. What this means in our picture is that we could have side A plus side B greater than side C, or we could have side A plus side C greater than side B, or lastly, we could have side B plus side C be greater than side A. Our third property says that the largest angle is opposite the largest side, and the smallest angle is opposite the smallest side. So in our picture, that would mean if angle A is greater than angle B, then side A must be greater than side B. Likewise, if angle A is less than angle B, then side A must be less than side B. Let's now look at some examples where we need to find the measure of some angles in a triangle. In our first problem, we need to find the measure of angle alpha. We start by using our first property that tells us that the sum of the three angles in a triangle is equal to 180 degrees. So we can write 25 degrees plus 110 degrees plus alpha is 180 degrees. So we add 25 and 110 and we get 135 degrees plus alpha is equal to 180 degrees. We can now solve for alpha by subtracting 135 from each side of the equation. So we have alpha is equal to 180 degrees minus 135 degrees, and we're left with 45 degrees. And let's go ahead and box that answer. That property really comes in handy when calculating angles. In our second and last example, we have a triangle where angle A is 3x degrees, angle B is 5x minus 3 degrees, and angle C is 47 degrees. We'll begin like we did in our first example, and we'll write down the angle A plus angle B plus angle C is 180 degrees. Now let's plug in what those angles are. Angle A is 3x. We can leave out the degrees for right now, and we'll put that in at the end. Plus angle B is 5x minus 3. Plus angle C is 47, and that all equals 180 degrees. Let's combine the variables and the numbers on the left-hand side. So 3x plus 5x is 8x, and then 47 minus 3 is 44. And on the right-hand side, we have 180. We want to solve for x, so we'll subtract 44 from each side of the equation. So that gives us 8x is 180 minus 44, which is 136. We'll now divide each side of the equation by 8. So we have x is 136 divided by 8, which is 17. Now, we're not quite done. We know what x is, but now we have to find what the angles are. So we'll go over here, and we'll say angle A is 3x. So this is 3 times 17, which is 51 degrees. Angle B is 5x minus 3, which is 5 times 17 minus 3. We're almost running out of room, but we do have enough room. So this gives us 85 minus 3, which is 82 degrees. And let's go ahead and box those answers. I often talk with students about built-in checks to be able to see if you've done a problem right. So one of the built-in checks with this type of a problem is that we can add all three angles up and make sure that they come to 180 degrees. So if we add 47 degrees plus 51 degrees plus 82 degrees, we can see that we have 180 degrees, and that means that we've done all of our algebra correctly. I would encourage you to review the definitions we've gone over and redo these last example problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.